Hello, everyone. This is Emmy Williamson coming at you from the channel of Flow Theory 101. This is the second in a two-part video series where I am repairing my lathe, which went bust on me recently. The power supply and speed controller died. And so in this first video, I went over the project. I introduced a power supply that I can use for this. And I also discussed the potential problem of varying the speed. Now here is the power supply, and it puts out a constant 26.5 volts, which is great. It runs the motor just fine, but it runs it at full speed. But with a lathe, you need to be able to vary the speed. And how you do that with a DC motor is you turn the voltage up and down. So in order to do that, I've taken this heat sink, which was part of the original package. This box was here, and it had this board mounted here, and it was on here. This is bad, so I'm going to throw this away, and I'm going to install this and this inside this box. This is the heatsink that it had before, and I'm going to use it as a cooling system for the MOSFET transistors. So this is also a good video if you're thinking about building your own speed controller or a transistor controlled system for any reason. This video goes in pretty good detail in that, and I'll be explaining the method of introducing a MOSFET, the N-type. There's P-type and N-type. N-type is the most common. It's the negative type, and it uses the negative current flow through the MOSFET, and it varies the voltage for you by varying the voltage at the gate. Okay, so on a transistor, you have three posts. See if I can zoom in on this. You have post number 1, which is the source, and then post number 2, going from right to left, is the drain, and then the post number 3 on the leftmost here is the gate. These two control the voltage going to the thing that you want to power. In this case, it's the motor for this lathe. So the power is going to come out here. It goes into the MOSFETs here, into the source, and it goes into this first post right here. And then it comes out the drain on the second post or the middle post, and goes here. And that feeds the DC powered motor, positive and the minus. This is the positive, it just goes direct there. And then the minus is the one that we're going to do the voltage adjusting with. Okay, so what do we have here with this mess? Now this is a temporary setup. I'm going to clean it up a little bit when I mount this in here and put it back in here, but I wanted to put it on the bench and test it and make sure that these MOSFETs were going to work. Now these MOSFET transistors are fairly common and easy to have. I bought this bag of about 15 of them. I think it was about 10 bucks a few years ago. They've just been sitting on the shelf. Looks like an IRF something. It's an N-type transistor, and they're just a few dollars each. This is way overkill having 5 of these. These don't even get warm when I run this, so I know it's going to be fine. This is a resistor. You're going to hear this term a lot when you're making these MOSFET deals. It's a pull-down resistor, and why you need that, it pulls your voltage down to 0 at your gate when you're not powering your gate. Now, let me talk a little bit about the gate. The gate is like a gate, like when you go in the backyard of your house, you open the gates, you go in, you close the gate, open, close gate. Gate allows, in the transistor context, allows the current to flow. So when you open the gate, you're applying voltage. Now, here's the trick. The MOSFET gate only requires about 3 to 5 volts typically. That's normally what they run. And so, but this makes 26 volts. So I need 5 volts to be able to control the power to go between 3 to 5 volts. So I have here another project. Now this is used to power my portable little stereo. So I'm going to put it back into use on that after this. I just wanted to use this for a test, and I'll make another one for the final on this. But this is basically a device that will take between 12 and 24 volts and make a nice constant 5 volts. And the way I accomplish that is with this transistor here. I don't know, you probably can't see that. That transistor in conjunction with this capacitor, and the capacitor is really important. You have to get the capacitor. This is I think it's a 25 volt, and it's a 47. Yeah, it's a 47 capacitor. And the capacitor goes between the output and the negative. And it's really important to put that capacitor on there when you're making a 5 volt voltage converter like this, because otherwise the transistor will get very hot. So you have to have a capacitor on this particular thing that I'm building, which is separate from this. This takes the power coming off of this. You can see the red and the black. It's taking this 26 volts and it's making a nice 5 volt output right here. This 5 volts right here is going to feed into this potentiometer and allow me to vary the voltage between 3 to 5 volts. Okay, so it's a small thing, but it's very important. Is you have to have a voltage appropriate for your gates, and with this simple little dealie here, I'm able to provide that, pulling power directly from the same power supply, so I don't have to have some other complicated power supply system. So I'm going to control the gate using the power from this, and then I'm going to control the voltage between 3 and 5 volts with this. Okay, so let's turn it on and see what happens. Okay, so right now it's running, and let's see what we got. We got 4.7 volts right here. Now this voltmeter is connected to where the gate is. So this is the output voltage from this, not this. Okay, this is 26 volts. This is 5 volts. Okay, and it comes out here and it goes here. Now here's the potentiometer, and you can hear the motor slowing way down, and the voltage is at 3 volts. That's the gate voltage. The gate voltage going into the gate here in the transistor. So it's basically closing the gate, so it's just barely open, and then very little power is going to flow out of the drain here, which is the center post of this MOSFET, and it's going to feed power into the motor. And here's the other on the motor. This is the positive, and this is the negative. Now with these MOSFETs, you're controlling the power through the negative. So the negative is here. It enters here into the source, which is the rightmost post in all these transistors. And by the way, this is a parallel system. These transistors are all set up in parallel. If I hooked up just one transistor, it would not have the power, the amperage, or the wattage to be able to power this motor at all. It wouldn't turn on at all. So what do? We put them in parallel. So all of the drain, all of the gate, and all of the source are all connected to each other. Okay, and then this resistor right here is called a pull down resistor, and you need that for when you turn off the power. When you set this power to 0, then the power to the gate goes to 0, and there's no float voltage that will impair the cessation of the transistor and close the gate completely. It's a minor thing, but it's important because sometimes. So here I am about an hour later. I've taken the circuit board and I basically re-tasked it, re-engineered it. You can see the transistor. It's got the 3 posts here on the bottom, 1, 2, 3, and the capacitor, which goes across the center post, which is negative, and the output post, which is the right post. And then that goes to this red wire here, which creates an output here. And I have my multimeter hooked up. power supply is running, feeding power to it through this red and black wire. And then, so if I take that red output wire and I touch it here, you can see 5 volts. We got a nice 5-volt output here with this transistor and the capacitor. And then I installed this heavy wire here, which connects to the block, and this powers this plug, which is going to be reused. This board came out of the original lathe, and I took and unsoldered all the pieces, but this piece remained, and that's the plug-in for the motor. So the motor already has a cord that's long enough, and I'll just put this plug back on the end of it. So I'll just reuse the same plug, and it'll be powered by this wire, which is going to go into the switch, and I'm reusing this switch also. This is a really nice switch. It switches both of the wires, so you can go forward and reverse. And so that's nice. So I'm going to use that again, and it goes in this same position here. So I'm reusing this, and this wire will be the final output, and it'll run to the switch, and we'll power the motor from these 2 middle posts, which are reversible with the inputs that come into here, plus and minus. You flip the switch and it reverses the polarity between these 2 outputs, which feed the motor there. So tomorrow I'm going to put this whole thing together and test it. Okay, here we are for a final unit test before I do final assembly. I always like to test everything really well before I put things back together or pile more things on top of more things. That way, if there's a problem, it's much easier to sort out while things are still apart. So that's part of my process, and I recommend that you do that, is really test things before you start putting them back together. So here I'm going to just talk quickly about what I have here. This is the 5-volt power supply that feeds 5 volts into the regulated power through this adjuster, this potentiometer, and that feeds power into the gate, which is going to open and close the gate, providing power to the drain. This red wire is the drain, and this green wire is the source. The source takes power from here, from the power supply. This is the power supply once again. So now what I've added additionally is this switch. This switch allows me to reverse the direction of the motor on the lathe. And I've also added this plug here, which feeds power directly to the motor. So I'll be able to reutilize that, because I had taken this board and I'd retasked it as a 5-volt power, regulated power, and also the plug for the actual final output for the motor. So here we go. Let's turn it on and see what happens. Okay, so immediately I see the motor is turned on. So starting to work. We got the power supply is obviously working, and the MOSFETs are providing limited voltage. Now let's turn up the power and see if we can. Okay, looks like it turns up. There's a moderate power. Okay, now I'm going to pull it all the way back to the lowest speed setting, and then I'm going to flip this switch right here, which is the direction changing switch. So let's see if that works. Good. And that changed direction again. Okay, excellent. So we've got our speed control, and we've got our direction change, 5 volts, MOSFETs, power supply. Looks like everything's working. I think we can put it back together and try to squeeze everything in this little box right here. I tested it. I think it should fit. Looks like everything should fit. So I'm going to go ahead and do that now. Okay, we have here the finished assembly unit ready to go on the machine. Just to go over things, this is the main power supply board. It made 24 volts. I turned it up to 26 by turning this adjusting pot right here, 26.6 volts actually. I reused the same switch for changing direction on the lathe. I'm using this power button to turn it on and off. This is actually emergency cutoff. So that turns it on, and that turns it off. I utilize this fuse here, and then this is the potentiometer that I added. So now I have control of the speed, and I can change the direction with that switch, that nice switch. The MOSFETs are back here, and they're powered by this 5-volt power supply, which I used the 24 volts or 26 volts, and then they make a nice 5 volts, and then the 5 volts goes through the potentiometer, which is here, to change the voltage at the gate in the transistor. So by upping and lowering the voltage between 3 to 5 volts, I'm able to change the speed of the motor. Okay, looks like it's pretty well set. I'm gonna go ahead and put it in on the machine now. I also went ahead and right here there was a screw block which was part of the power supply, but I didn't need it because this is like a a finished assembly. I can just solder it. So I unsoldered this. I removed it. It was right here, and it didn't really fit with this big switch right here. So I cut it. I took it off the front just by unsoldering it. And it's nice. I have this thing. I can use it for other projects. I'm going to put it in the stock there. Now this was the heat sink for the power supply. It had 2 screw attachments here and here. But this is the This is the heat sink that was in the lathe, and I've been able to recycle it by drilling it here and here. And there's 2 MOSFETs, 2 big MOSFETs underneath this circuit board on the bottom, and they're now heat sinked onto this nice thick heavy heat sink. So this is a substitution for the original equipment with the power supply, and I think it should be sufficient, and it fits nicely in the case. Okay, this is the final presentation of the power supply and control system installed and functioning. This is the control box that I did the work in. The power supply is inside here, and with the MOSFETs and the 5-volt supply to the gate voltage of the MOSFETs, controlled by this potentiometer. Let's turn it on and see what happens. This is going in the forward direction. You can turn it up, you can turn it down, way down. You can change direction. Emergency cutoff. And auto feed, everything seems to be working. So, successful completion of the project. Installing my own control system and my own power supply, and everything's working great. Ready to put this baby back into service. Thanks for watching, and put your comments below. Thanks.